Hello again. Welcome to this year's Balcon. We are a bit late, but we are ready now. Vida will talk about the power of open sourcing. The topic is GrassGIS. So please welcome her and enjoy the talk.
Hello everyone. Today I'll speak about GrassGIS, power of open sourcing, and Python in GrassGIS. And let's see. But first, I'll speak about definition of GrassGIS. GrassGIS is a graphic resource analysis support system, commonly referred as GrassGIS. That's open source system in GIS, and it's published like GNU General Public License since 1999. Then it's a portable system, and we can install it on Linux, Mac OS, MS Windows, and other devices. But first, brief history. GrassGIS was born in early 80s. It was developed in American Army in Texas developed this GIS system. It was for use to show some ecological system and data, but nowadays GrassGIS has seven. How to say? Today we have 7 different types of GrassGIS. Now the 7th version is a stable version, and we can use it nowadays. It's written in C language, but on version 6 GrassGIS came in Python language. It's easier to write and understand for developers, so that was the best. Now, in these days, stable version is GrassGIS 7. It's available since 2015. It offers large data support and improvement topological 2D or 3D vector engine and much improved vector network analysis. The best thing about GrassGIS 7 version is full temporal framework, and there we can analyze different images from 2 or 3 types of time, and we can analyze these changes in time. Image processing have been extended. Many new options have been added. For example, for image processing, we can now analyze albedo, biomass, then soil heat flux, then in vector processing there is faster data import. We can make kriging and new spatial indexes but for these vector analyses there isn't so much memory required. In general support, it's globally enabled and it's improved Python API. We can read, write, grass refers to and from NumPy, and VPS is supported. That means it's implemented in parser like C, C++, Python, and Shell. Just a moment. Actually, the question is who is using GRASS? As any open source program, there is a lot of users, not just in commercial, but currently GrassGIS is used in academic, commercial purposes, as well as many governmental agencies, including NASA, NOAA, USD, DLR, CSR, and the National Park Service. On this map, you can see that GrassGIS is excuse me. GrassGIS is mostly used in Europe than in America, actually South America, and a little bit in Asia. Now let's talk about capabilities. GrassGIS can do with raster and 2D and 3D topology vectors. Then voxel support, vector network analysis support, image processing system. We can visualize system, and GrassGIS is linkable to different types of database like SQL, PostgreSQL, MySQL, and SQL drivers. Raster analyze, that means that we can automatic raster line and area to vector conversion. Then we can buffer line structures, cell and profile data query. We can put color table in these maps, and then we can make conversion to vector and point data format. In GrassGIS, we can use different data types like 2D raster data, including image processing, 3D voxel data for volumetric data, 2D or 3D vector data with topology, and multidimensional points data. Raster geometry is presented in cell matrix with coordinates, and resolution is defined with cells width and height, and resolution can be in kilometers, meters, degrees. But vector geometry is presented like a point, centroid, line, boundary, area. Geometry is through 3D. That means we have X, Y, and Z coordinates to present vector data. These are some commands that we can use in GrassGIS. For example, every of these commands have some prefixes that they can show us for which function is specialized. For example, prefix D means is used for function display. That is a command for graphical output. Then R prefix is for raster function, and it's for presenting raster data and processing with them. Of course, V is for vector and processing with vector data. I will show you some examples with these functions, but important thing to mention is that Grass always import complete map. But when we want export, we should to cut our area of interest, and with export vector, we always get the entire map, With raster, we have two different functions where we can define will we get a map in original resolution or map in resolution at current region resolution. These different functions are r.out gdale and r.out tiff. Region is a current working area, and important thing is when we make some calculations with vectors, these calculations are made on whole map, but on raster calculation, these calculations are made just on current region. That means if we are positioned under Serbia, these calculations will made just under Serbia, not on whole Balkan, if map is a Balkan map. Now, examples will be later, it's better. This is when we start with the GrassGIS. We can get this dialog box, and there we must position where is data, then choose location and map set. Map set is very important to choose because that define our coordinate system. Then when we choose all these, just start Grass session. And we get this. Now, these are two windows where we will display our data and analyze them. Close file, map display, and add raster. There we choose which one map we will show. For example, it would be elevation, and then OK. This is one example of map in GrassGIS. But we can, of course, make different type of thematic maps and make analyses. For example, vector map. Railroads, and OK. And on this map, we'll show railroads on this area. For example, we can make some analysis like shaded relief map. It would be terrain analysis. Terrain analysis, and here we can see these functions in squares. R means that we are using raster, and slope. And now we can choose which one of these functions will be used for our next map. For example, we'll generate contour lines. Here we should input raster name of input. It would be elevation. Name of output. Contour levels. That's important that we must define these. For example, 20, and run. Now on our map we can see all these contour lines, and that's great. But look at here, we have Python shell, and what about if we need more options? Look at, just for a moment, I'll show you GrassGIS architecture. And we can see that as any open source program, we can make some code for this program, and we can make some improvements. And on this, we can see that Python is very important in developing with GrassGIS architecture. Python's cup of tea, it's innovation that started with 6 version of GrassGIS. GrassGIS started with scripts in Python because that's easier way to improve GrassGIS, and in GrassGIS 7 Python is default language for creating add-ons. There are too many Python libraries included in GrassGIS, but all of them are divided into two parts, for raster and for vector. On these two sites you can find out many of the examples of these scripts, and on this picture is one simple script for opening, query and closing of vector map. It's true that GrassGIS have over 400 different functions we can use, but what if there isn't our function that we just need in that moment? The best way is to write a sample script. These scripts we can find out in PyGrass library. The PyGrass library have many examples, and on GitHub also we can find these Python scripts that can help us to solve our problem. And code as a model is improvement in GrassGIS 7 version, where we can make our model, and we can look on this model in Python editor. For advanced user, that's advantage, because we can make our model, and in Python editor we can make some some changes, but for users who are not as good as in programming, these models are the best way to make their own function and make some improvements in their analysis. Oh, I can show you. On GrassGIS site, there is a programmer's manual with programmer's manual where we can I'm sorry. In these libraries, we can find out some codes that can help us to solve our problem and make improvements. Every new Python script which really is uploaded on site will be new script will be uploaded, and every month we get these add-ons and updates where we can use them if they are good. We can use them, and on that way we improve every version of GrassGIS. Just a moment. And we can now go to program. As I said, Python shell. Here we can make with Python some changes, and here is a graphic modeler where we can make some models. Here we can say add command, add data, and here is also Python editor. If you don't like to work with model, you can code here directly and use your script in analysis. Okay. For example, add command. We can choose which of these, of course. If we want to make some command with some model with raster command, we choose one of these. If one we make with vector or database, we can choose one of these, and then OK. Make this. Okay. In Python editor, we should get these in command. Oh, no. Of course, there is a lot of tutorials for learning coding in Python and GrassGIS scripting. And for fun of Star Trek, there is one video from 1987 where Captain Kirk speaks about improvements and coding, and he says, don't keep your information about soils, vegetation, roads, or archaeological sites rolled up in map tubes or stuffed into drummers, keep it in a computer. So he said that we all need to work with maps. If we work with it, that's the best way on computer, and the best way to make some improvements is to give our contribution through making some scripts and coding. Thank you, and sorry for this inconvenience.